Hello, everyone, and welcome to Hoot number 67. So today I'm joined by Jacob Bohanon. Bohanon, Jacob is a senior software engineer, and today we'll talk about how to extend your data plane out of processing using Envoy's external processing filter, right? Am I
Yeah,
correct? That's right. All right, perfect. How are you doing, Jacob?
doing pretty well. How are you doing?
I'm all right. It's nice and gloomy and rainy here in Seattle, so nothing's new. It's the same weather as usual. Um, all right. So for audience, anyone watching, if you have any questions, feel free to use the comment section, ask questions, give us your feedback, give us your comments, and well, I'll switch over to the screen. And Jacob, it's up to you.
Awesome. Thanks, Peter. Um, yeah, as mentioned, we're going to be talking about Envoy's external processing, which is an HTTP filter in Envoy that allows you to manipulate the proxy from outside of the binary process itself. So, like Peter mentioned, my name's Jacob. I've been contributing to the Envoy project as part of my work here at Solo for a little over a year. Most recently, I helped implement some new features in the external processing filter, which I got to know pretty well in that time. We'll be starting today with a broad overview of Envoy architecture, focusing on the HTTP filter processing. From there, we'll talk more specifically about the external processing filter, what it is and what it does and how. And then we'll contrast the external processing filter against some other out-of-process options, such as Wasm, Lua, or the um, developmental Golang filter. And then we'll wrap up with a quick demonstration and some Q&A as time allows. So what is Envoy? A little bit about it here. Envoy is a cloud-native proxy designed from the ground up over at Lyft several years back to solve issues that surface from adopting microservices microservices architecture. Its architecture makes it highly extensible as well as performant. And among the many use cases that Envoy has been deployed into, we here at Solo have built Blue Edge on top of Envoy as an industry-leading API gateway solution. All right, brief overview of the architecture so we can get some reference for what we're talking about. Key concept we'll talk about here a lot, and this is Envoy's filters and filter chains. A filter is simply a bit of code that Envoy will execute during the life cycle of a request. There may be many different events about the request which Envoy will let the filter know, and proxy operations and decisions can be made from those filters. A filter chain is just an ordered list of filters to be executed one after the other. So a little bit about under the hood when Envoy receives a request to be proxied. First, it'll receive that TCP connection from the kernel, and then it runs a filter chain on the socket itself, comprised of what's known as listener filters. It's a pretty short uh, list of listener filters because there's not a whole lot of information that's actually been unpacked yet at this point. Um, this is the list of them here. At that point, Envoy will then construct and run the layer 3 and layer 4 filters to operate on the actual TCP data. Slightly longer list here, but the key one that we're going to be talking about here, and the last one that will run for any HTTP proxy request, is the HTTP connection manager. And that will always be the last filter on the network filter chain. The HTTP connection manager does exactly what the name implies. It'll handle all of the layer 7 operations on the request. Uh, each request as it's received will be processed by the codec. This graphic, all these graphics were pulled from the life of a request document in Envoy's documentation. Long but great read. Even HTTP1 requests will be abstracted as a stream. You can see stream mentioned here, stream 0, stream 2, and each stream has a unique filter chain constructed to process it. Filters are then executed one by one along the chain for request lifecycle events. Some of these events receiving headers, receiving body data, finally receiving trailers when the stream completes, and there's a few others. But for each of these events, Envoy will walk down the filters and execute the code on each of them. At any point in that execution, a filter can say, "Hey, stop what you're doing. We gotta cut it out," and either wait to continue iterating on filters later, or tell Envoy to just send a response immediately back to the downstream. External processing is a filter that operates both when encoding an incoming request, both when decoding an incoming request, so taking the bytes off the wire and turning them into something meaningful, and then encoding the outgoing response, so taking the meaning that you have and sending it back to the downstream. In general, HTTP filters can operate on one or both of those paths, and in the order that they are listed in the filter chain, they'll be executed straight across for the request path, which is the decode path, and any decoding filters will be executed. And then this arrow points off. Then the request goes off to the upstream, the final target. The upstream sends its response back to Envoy, and Envoy will run the filters that have encoding logic in reverse order. This is especially important when sending dynamic metadata that's encoded from other filters, or receiving dynamic metadata that might be used by other filters. For example, if filter A on the encode path was the one that emitted dynamic metadata, it wouldn't exist at the time that filter B was running because it's executed in reverse order. Okay.
So just to before just to recap for my understanding. So when the request comes in to the Envoy proxy, there's a listener filter, right? There's a one or more, and those are just listening on ports, for example, right, or something like a network address. And then the listener filter, I remember there's a feature also in Envoy that allows you to basically pick which filter chain. So you can have multiple of these different filter chains defined, and then based on whether it's plain text, right? That's what Istio does, right? Whether it's plain text or if it's mutual TLS, there's one or other chain that gets executed. And then that chain, network chain, is comprised of network filters. And then one of those network filters is this special HTTP connection manager filter, right?
Yes. Correct.
And then the thing that was always like not confusing, but I mean, Envoy in general, to me, when I started looking at it, is like, oh, like there's so many of these things. And it was when you were talking about the listeners here, you said, well, there's only a couple of here. There's not a lot. And I'm like, yeah, well, compared to what do you have in the network filter list, right? Yeah, there's not a lot of them. But there's a lot of stuff in Envoy. It's very configurable. It's a generic proxy, right? So that's expected. But what I was wanting to say is, so HTTP Connection Manager is a network filter, right? But HTTP Connection Manager also has a set of HTTP filters, right? That you can define. That's another ordered list of filters inside the HCM, right?
Yes. And I actually thought about putting those. I'll pull that up really fast, but I thought about putting this same list, um, this same little green list for HTTP filters, but it doesn't fit on one screen. I probably
Yeah.
couldn't chop it up to fit on to the slide. There's just so many of them.
Yeah.
Um,
Yeah.
I'm
Yeah.
actually not going to be able to find it
Yeah.
as
There's
fast
a
as I would
lot of,
like.
yeah, but I mean, it's like if you think there's a lot of like listener filters, well, you haven't seen the list of HTTP filters. There's one for everything, which is great, right? It's great because it basically it allows you to do pretty much whatever you want, right? Because there's so many different things that you can configure, and you can put these in wherever you want, right? And I guess in the order and in the chain, right? So, all right, yeah. Sorry for stopping you.
No, that's great. That's a great segue actually to talk about. There's a huge long list, and the Envoy documentation does a good job of talking about all of them, but all the filters that come baked into the proxy that you can configure and use. But no proxy could possibly come up with an exhaustive list of all
Mm,
of the different things you might want to do on a request, at different ways to process it. So that's where the external processing filter actually kind of comes into play. It's one of a handful that I mentioned of different uh, ways to process a request and kind of hook into these lifecycle events that exist outside of the actual running process of Envoy itself. Um, what's unique about the external processing filter among these others, the Wasm and Lua and the Golang filter, is that it's actually a gRPC service uh, that is running anywhere, does not have to be co-located with Envoy, and as long as the gRPC server implements the correct API, then it can interact. You can configure Envoy to send these processing requests out to it, and it can interact. Um, this is really hugely beneficial in large organizations where you've the person or persons that are writing the applications and might have interest in the proxying behavior aren't the same people who operate the managing the configuration and deployment
mm,
of the actual server. Um, it allows for a great separation of concerns there. Um, the external processing filter actually just flipped to be marked as stable in upstream Envoy for the release of 1.29. Um, so that was exciting. The
mm.
security posture also changed to be robust to downstream traffic. So
So if I like I've seen this filter, it's there, but if I know you mentioned Lua and you mentioned Wasm, and correct me if I'm wrong in my thinking about it. So Wasm, if I want to do, if I want to create a Wasm extension with my own piece of functionality that I want to run as part of the request flow or packet flow, I would have to build the Wasm extension. I would have to deploy that Wasm extension and then configure my Envoy filter to load and or use that Wasm extension. And then similarly for Lua, right? I would have to actually write a script and then tell Envoy, hey, here's the script, load it and run it as part of the flow. Whereas with external processing, if I already have a gRPC service that corresponds to the interface that Envoy is expecting me to implement, right? If it, I think that's the right way to say it. Then that's all I need, right? It's like I don't have to necessarily tell Envoy to download something. I don't have to tell Envoy to. I'm just basically I'm assuming in the configuration there's just a address where we're telling Envoy, hey, go there and call it.
yeah, absolutely. Um, that's exactly correct. And there's a configuration in the external processing when you're setting the configuration for that filter that allows you to fail open. So for some use cases, you might be using the processor to make decisions, and you want to maybe give it a hard no. Tell it it's not an external auth service, but you could use it for things that are similar to that functionality. And you might want to be able to say, no, I don't want you to fail open because uh, I need to know for certain that it passes these tests that are running in the external processing server.
Mm.
Or if it's just kind of firing stuff off to say, hey, I'm collecting some data or we're aggregating some stuff and we're using the external processing server to do it, then you can fail open so that if you can't access that service,
Just
then the
ignore
request
it.
just proceeds as usual.
Ah,
Yeah.
okay, okay, okay.
Uh, yes. So uh, some more, you mentioned it's a gRPC service, uses um, bidirectional streaming. What that means is that the request, when the filter is constructed, it'll open up a connection or open a stream to the external processing server. And on these various request lifecycle events, headers, body, and trailers for the request and the response direction, all configurable, different messages will be sent to the service. So there's one stream open and communication will happen between Envoy and the service via messages being sent on that stream. Um, Based on what the processing service decides to do and respond with, the headers, body, or trailers, just about anything about the response or request can be manipulated, um, including instructing Envoy, like I said, to not process anything further about the request. It doesn't even go to the upstream, and we're going to send an immediate response to the downstream. Um, One of the things that's not exactly downstream or upstream facing is the ability to add and modify dynamic metadata. Uh, Dynamic metadata is a construct in Envoy that allows filters to share information with other filters. It goes onto the information that Envoy is keeping track of with regard to that request. There's a handful of attributes also that Envoy has kind of handily abstracted into one place. This hyperlink um, would would take you there. I'll just open it up real quick to show quickly there's a whole bunch of attributes that are available elsewhere, uh, like you could access the headers and stuff, but you can use these attributes to send this information to the processing server.
Okay, so basically you can tell Envoy when you're calling the external service, right, or server, you can send all these attributes, and then I'm thinking of like a use case, right? Like you could configure it to send let's say a path, just to be very simplistic, right? URI path, you can send that, and then you can have your external server take that path and then create some metadata value with some key, and then if I understand correctly, you can send that back and actually set it so
Yeah,
any subsequent filter that runs after this external processing can access that data. Is that correct?
yeah, exactly correct. And the dynamic metadata and the attributes features here were actually the features that I mentioned earlier that I had helped implement, and those are available or will be available once Envoy 1.30 is
Hmm.
released. So it's
So
fairly recent.
yeah, so I'm thinking, would this allow me to, let's say, rate limiting, for example, right? Rate limiting right now in Envoy, I think there's an external service that you can hook into, right? And then it has like a set of configuration where you can determine whether the request should be rate limited or not. Could I somehow use this external server to, based on some attributes, calculate whether the request should be rate limited or not on my own without using rate limiting service, for example, right? Send that back and then use that metadata value in the actual rate limiting to say, hey, check if this is true or false, and then rate limit or not, I guess.
Yeah, you could do that. You could also use external processing simply as kind of a ham-handed rate limiter, because you're sending the information to it. It's got access to everything that, or you can configure it to have access to everything that the rate limiting service would end up having access to. And what you could do, I mean, I want to be clear that it's not a cut and dry like replacement for rate limiting XOF, etc.
Yeah.
And but it could perform a lot of those features. There, the other ones that are more specifically designed to do that are probably the better option if you've only got that one thing to do. But for example, if you're doing rate limiting and auth and tapping requests, it might be something worth looking into to just send something to external processing, have it run through all of these different things real quick, and send back a decision
Yeah.
to Envoy.
I guess there would be I'm thinking two scenarios, like specifically rate limiting, right? Let's say you could implement it on your own and say, hey, I don't want to use any of the existing rate limiting filter that Envoy already has, because Envoy has those, right?
Yes.
And then you would just say true, false, or stop processing, and that's it, or continue processing. But then the second one, I think that's the one that I was thinking about, is I would send some metadata or some attributes over, make a decision whether, or not make a decision, set a metadata value, and then send it back. And then in the existing Envoy rate limiting filter, I would access that metadata value to make a decision based on that, I guess.
Yeah, that'd be a great use case as well. Absolutely.
That's awesome. Like this sounds like an excellent filter that allows you to a lot of things.
It's BYOF really. It's bring your own filter to Envoy. So this is from the design doc quite a while ago, but it still holds. This is walking through the events that occur for a headers only check. So what's going to happen? We've got the downstream Envoy. The filter server, as called here, is the processing server, and the upstream. So the downstream will send the headers. Envoy decodes those, and then sends the request. Envoy decodes the request headers, and then sends those over to the processing server. Processing server does whatever logic it has, sends the specific message for responding to a request headers message. And then in this case, since we're only checking the headers, the processing server will actually close the stream. And what that does is it tells Envoy, hey, we're done here. You don't need to, even if we've configured other things to be sent, don't worry about it. You don't have to send me anything. And so at that point, the request looks just like it would, as if there were no processing server.
So it's basically this filter. The way that I think about this is you basically have the like event handlers. I don't know if that's the right word to say in your filter server. You're basically saying, hey, if this method or this function gets called whenever the request headers are sent, and then you can do some, like in this example, request headers is called, you have some piece of code there or something that gets called, and then you return that. And since you don't listen to any other or you haven't configured anything, it just goes as if there wasn't any filter server in between after that, right?
That's exactly correct. Yep.
Awesome.
All right. I'll touch real quick on the support that we have for Glue Edge. We have for the external processing in Glue Edge. It was support was first released with 1.15 of Glue Edge Enterprise, and it could be with Edge configuration. You can configure an external processing filter, and the filter can be configured either globally to apply to everything that Edge proxies, or at the listener, virtual host, or the route level. Just about everything. I'm pretty sure everything that you can configure on the external processing filter can be configured here on the Edge configuration, and it gets translated down to the Envoy configuration. And for the attributes and metadata, since we developed those in-house, those are actually already available in Glue Edge, even though they're not released yet in upstream Envoy. So brief chat about the other out of band, out of the box, out of process functionality, the Wasm, the Lua, and the Golang filters. The big thing that each of these has is that they're not making a network request. They're co-located. They're either, I mean, the script execution is really fast these days with the just-in-time executor, and for Lua, and then for Wasm is running production all over the place. That's a binary compiled. That's got all that performance baked in. With external processing, you are making a gRPC network request that's going over the wire. That adds some latency. The benefits that we talked about earlier come into play there, where the separation of concerns, the rapid deployment, etc. So the cons for each of these being co-located, Lua and Golang can only be written in Lua or Go, as as implied by the filters themselves. A gRPC service, anything that's got a gRPC client, like Java, Go, C++, anything that you can do, you can implement this API and run your server in a polyglot kind of way. I mentioned Wasm is a great option for use cases where the plugin developer has access to that proxy deployment to deploy their plugins, or when the latency introduced by the network hop is just not as acceptable.
And also,
right.
wouldn't, if you're, let's say you're doing a Wasm, you're using Wasm, you're using Go, right, to write your extension. How would be with the code reuse or library reuse, right? Wasm doesn't support everything, right? It doesn't support all the right libraries and frameworks, if I remember correctly, right? You can't use everything because it's like a subset of like Go in this example, right? It's a subset of Go SDK, I guess.
Yeah, I've really not looked a whole bunch into creating Wasm plugins. What I did see was that you have to use TinyGo, at least for one particular SDK that I saw. I don't know if there are others,
Yeah.
but what I saw, you have to use TinyGo, which is a separate compiler implementation. So
Yeah,
yeah,
and then
that's
if you're doing the external processing thing, and let's assume you're using Go as well, you basically have access to the full framework for all of the libraries. It's the same Go compiler, right?
yeah,
I was going with I'm assuming it's an easier way to reuse code as well, maybe, right? Because it's compiled with the same Go compiler that you're using for the rest of your code base, versus it's not a subset of something, right?
yeah. That's a good point. All right, dive into a quick demonstration. Um, I have here a Envoy running, and a processing server, and an HTTP server that just responds in specific ways. This is largely taken from the Google Cloud Platform uh, uh, external processing examples repository on GitHub. I've made a few tweaks, but it's mostly that. So here configured, I'll walk through some of the less than nicely readable Envoy configuration. All this is really saying we're going to be listening on port 10,000 on localhost in our HTTP connection manager, which we spoke about a bit, where you've configured an access log. The access log is just going to spit out dynamic metadata from this namespace. The external processor filter config here is going to say that we are going to send request headers, response headers. It's configured to send request trailers. That's not going to be a part of this demo. And then the request body is going to be sent. And the buffered mode, as opposed to streamed, buffered means that it'll take the whole body that it gets from the request up to a configured limit and send it all at once. Whereas with streaming, you can send
like chunks or
chunks.
something. Yeah.
Yeah.
Oh, so this is where you basically define what you want to receive or what you will get, or what will Envoy send to that Envoy _, gRPC, whatever is defined between that processor cluster name, right? I'll send it there, right?
Yes, exactly. And kind of a key point is that any of these messages that aren't relevant to the request, there's not a message sent for it. So even though we've configured request trailers to be sent, if a request comes through that has no trailers, the processing server is not going to get an empty processing request for trailers.
So it's optimized in a way, right? So it's not right sending what it's not there.
Right. It's not going to waste cycles on that. Here we've configured the attribute of source.address to be sent, where the connection was made from when Envoy receives it. And then we're going to send response attributes. That's not a part of this demo. For metadata options, we've configured it to allow the receiving namespaces. And what this means is that the processing server can send back kind of whatever it wants for dynamic metadata. But if the namespace isn't in this list, then Envoy will not write it. However, if the namespace is in this list, then Envoy will write it. And where that's powerful is that this is the key for the external processing server. But for example, the metadata key for xauth looks exactly the same, except it says x_authz.
So you could set, basically you could set, if you place this filter before the authz filter, you could set some metadata into that namespace there, and then the authz would be able to read it and access it.
Yeah, and so because that's because metadata is used so throughout the filter processing, the receiving namespaces defines exactly which namespaces you are allowed to write over, and it will overwrite the entire metadata at that space. It's not going to merge it or anything.
Okay.
I believe that's everything that's interesting here.
Yeah, and can you just show the processor cluster name? That's just where the where your processor is running, right? And it looks like you're just using a pipe, right?
Yeah.
The socket there, right?
Yeah. Since I'm running it all locally, I've configured it to use a Unix socket.
Yeah, and this could be theoretically an IP address running somewhere else, right?
Absolutely. And it could be load balanced. Like this is just any
Ye-
cluster if you've got multiple instances. Yep. All right. Moving on to the demonstration, I've got these servers outputting to log files, and we're going to see the Envoy logs come across here. The external processor logs, some things, we'll see that here, and then the access log that we can configure, that we show that configuration for over here. The first request I'm going to send here is going to add headers to the request and to the response that is going to have the hash of this hello world uh, body here that we've included. So when I send that request, what happened under the hood, I'll go through and explain. This says echo hash buffered. All right. So this is the processor log we're looking at here in the middle. First request, and it's got all the information that the processing server received. It went ahead and set the path to /echo. That's what our upstream server is expecting. So it rewrote the path and then received the request body, and it added this request body hash header in there. On the response path, it did exactly the same thing. This /echo in our HTTP target is just going to echo back hello world back onto the response body. And so we see we've got X response body hash is the exact same hash.
And this is the whole, like, you had a slide encoding, decoding path, right? On the way in, right, it did the request body, right, got the request headers, and then on the way back, it got the response headers and set the response body, etc., and then changed it, right?
Exactly correct. So the next request that I'm going to send is going to, and I've got the code for these this processing if that's something we want to look at. But I'll send a request to a processing handler that's just designed to check the attribute source.address and see if it starts with 127 and then block it as a local host. So when I sent this request, we've gotten back a forbidden response 403, and the processing server rewrote the body to say to send an immediate response. Request may not be made from localhost. We can see in the processor logs here, we received the request headers and we've blocked the request.
So from the processing server, you can also then specify which HTTP status code you want to return, right? You can say 403 in this case, or you could say whatever else you wanted to, right?
Absolutely. A great use case for external processing is receiving or on the response path. I think one of our folks is working on or has published a blog post about this, but on the response path to receive a non-OK response and then actually transform that entire response into like a custom error message, or for example, say you need your downstream needs to have HTTP, you can take any JSON error message and go ahead and you can do that with transformations too. A lot of what you can do, some things that you can do with external processing are net new, and you can do a lot of things with external processing that you can do elsewhere, and maybe you're able to combine different things into one central logic location. All right, I will send one last request to show off the ability to write the dynamic metadata. We're going to send a request to an endpoint that the processor is going to decide to respond with setting the external processing dynamic metadata, then we should see it arrive over here in the access logs when the access logs flush. Yeah. So
There
here
you
we
go.
see that we in that xproc dynamic metadata namespace, we went ahead and got the from header Scooby-Doo dynamic metadata.
And this looks like, oh, big deal. You got something to log out there, but it's actually extremely powerful because there's no, like, this dynamic metadata, from what I understand, is it is the way for Envoy filters to share information between them, right? There's no other, I don't know if there's another way to do it or not, but this is extremely powerful, right? Because you could decide to set some values or whatever you want is dynamic in this dynamic metadata in order for any subsequent filters to read it and use it and make decisions based on that later on, right?
Yes, there's the other major way to share data between filters is filter state. They've got pros and cons to do. I don't, uh, frankly, remember them strongly enough to enumerate them, but they're subtly different. And dynamic metadata has been the one that I've seen used more recently to share this filter state. And yeah, like you said, logging it, not that exciting. The only reason that's a part of the demo is that it's so internal to Envoy that it's you do things with it elsewhere inside of Envoy. So this is just kind of the way to show that it was actually put in there because we can get it at the end of the request with the logs.
Yeah, yeah. And it's nice because it's basically, instead of like a lot of times there are things that you hard code an Envoy configuration. Oh, this path, that path, this, or filter has to know some things beforehand, right? Any filter, right? But this will then allow you to dynamically maybe change the behavior or make something generic, more generic, instead of hard coding it, right? Or anything like that. So yeah, this is really nice.
Excellent.
Can
That
you
was
show like the code that actually, like, how does, I'm curious how that interface looks like, or the actual thing that you have to implement in order to make this work.
Yeah, absolutely. So this is all the code for the servers between this main.go and service.go. Main has got a bunch of gRPC
Setup.
set up. We're listening on the socket, and then we register the gRPC service as an external processor server. Into the fun part, we will process. This is what's actually implementing the gRPC. This is what's defined in
In that
the
interface, is that the
interface.
only function that's there, or
It is, and the reason for that is because this actually receives a stream as its argument, and so it process will receive the stream, and then at that point, communication is open between Envoy and the processing server. Envoy doesn't send more RPC requests; it just sends messages on this stream, and so the server has to be set up to receive off of that stream and process these messages appropriately. We'll see a lot. First message. This is the message that we receive here that shows all the stuff that we got.
and all the stuff that we got here is whatever you configured in the configuration, right?
Um,
Right, where you said like sand, was it sand or something?
Yes and no. So the first message will be the request headers for this particular server. The way that this server is set up, and it doesn't have to be that way, but the way that the server is set up, it expects a request headers message first. So if
Okay.
you skipped that, then this server would not handle that particularly well. In fact, it would just log a warning and close the stream.
Okay.
Um, so from there, we go ahead and get that header value because we're processing based on the path that we receive. Um, so we get the header value. There's a whole bunch of handlers defined here. All of these four are just going to um, they're just going to receive the message. This is kind of just an ACK. It's an empty response to say yes, I got it, because Envoy requires a response to each processing request that is sent.
Mhm.
So it's just going to log out that we got a specific kind of message and then send the response.
Okay. And the reason there's a 4 here is because it's a stream, right? So we're
Yeah. So Envoy could send, and the way that we've got it configured here is we'll send request headers, then request body, then the request trailers. All of these messages could be coming, and what that for loop is doing is
just
saying,
reading them until there is something to read.
yeah, read handle, continue, read handle,
Mhm.
continue, until we hear about the stream being closed, then just return out. That's not where I wanted to go. Okay, so some of the ones that we were just looking at, echo hash buffered, for example. This is a uh, fairly lengthy function here, but what it's going to do is it sends a response to um, the request headers message, which is the first one we receive. So when we enter this function, we know that we're handling a request headers message.
Because of that
It's
check that we did in the main or the process function, right? Where we check for that first.
exactly. So we're going to respond to that message by saying, hey, rewrite the path to /echo, because that's what we want the upstream to receive. Or that's what we're trying to reach on the upstream. And we're also going to, what is the mode?
Mode is being passed in,
Yeah.
right? Yeah.
Yes. So this is also saying we're going to, the mode was buffered, and we're going to go ahead and set you can tell Envoy to override that mode that we configured in a request headers response.
Oh.
You can tell Envoy to change subsequent behavior. You can also configure Envoy to not allow the server to do that.
Yeah.
But that is an option, and that's what we're doing here.
So it's just showing all the different ways that you could, like how generic it is and how like flexible it is and all the things that you could actually do, right?
Absolutely. Yeah. And then the send immediate response here is this is one that was used several places. We used it for the blocking a local host, for example. You can create a response to a message, any message, called an immediate response, and include all of these details about what you want to do, or what you want to send back.
So this reminds me of the direct response functionality. It's similar in a way, right? Where you
It
can
actually
just
turns
say direct response, just set this body, set this status, and that's it.
Yeah, it actually configures a direct response. Um,
Oh, behind the scenes, actually, like in the implementation, that's what it uses.
exactly. So I'll see if I can. Uh, well,
Immediate.
yeah, send immediate response. So when we receive that message, what we're going to do is mutate headers, um, et cetera, and then
Oh,
we're
there is
just
a
going to
local
go ahead,
reply. Yeah.
send
That's
local reply.
yeah,
Yeah,
yeah, yeah. Oh, awesome! It's nice to see how everything comes together.
yeah. So that's um, about it for the demo. I don't know that we've. I want this maximized. All right. Um, that was all for the demo and all for my slides.
All right. Well, there are a bunch of people watching, especially on LinkedIn. So if anyone has any questions for Jacob, now would be the right time to ask. Um, I know LinkedIn is a little bit behind on streaming, so we're like at least 3 minutes behind there. So people are still watching the whatever we talked about on dynamic metadata. So it's
All right.
far back, um, but
We can.
nonetheless, like if people have questions, they'll ask on in the comments there anyway, and we'll respond afterwards. But this was very useful. Like sometimes I make these episodes just for me because I'm interested in some of the topics that are presented, and this was definitely one of them. I did play with Envoy a lot, but there's always so many different things. It's a lot of different building blocks, right, that come together somehow, and figuring everything out is just it can be very overwhelming, I guess. So this was very helpful to understand, right, how you could use configure and this is just a single filter that we were talking about, right? A single but very powerful filter, right? Because it allows you to do processing on your own outside of Envoy, let alone the other 30 filters or how many there are. Uh, so for the use cases, I know we mentioned like external auth, right? That was one that we kind of mentioned that you could use this for, specifically with also either making an auth decision, right? And saying right away yes or no, like allow or deny, or doing something with dynamic metadata and passing that data on to the authorization filter later on. Um, we talked about rate limiting, right? With the same trick of setting the dynamic metadata and then having the filter use that. Um, are there any other like use cases? Oh, I know you mentioned the request transformation, right? Or response transformation, not request transformation. So let's say you always want to respond with a, I guess, uniform response message, whatever
Mhm.
that is, let's say some JSON, whatever. You could use this external processing filter to, on the response side, right, when stuff is coming back, you could take whatever the response was and then transform it in any way, shape, or form that you want. So you get that uniformity. Was there anything else? Like I'm thinking, any other scenarios that come to mind where this would be useful?
Um, Again, mirroring the earlier sentiment that you can do a lot of things in Envoy already. If you have there's a tap filter um, that Solo has actually put some work into um, recently, where you can wiretap your requests basically and send them to a specific sync. In Glue Edge, you can send them to a gRPC service. Um, that could also be implemented. The filter is designed with specific safeguards, and the filter is should be used whenever you can. But if you need to expand past or something, external processing can be used to achieve a similar effect. Or if you are simply there's an asynchronous mode that is in the API that's not implemented yet. However, if you simply wanted the data that it's going on in a request for whatever to do some intrusion detection or some other stuff that's kind of asynchronous, you can receive the message, the processing request message, and then just send an empty reply and do whatever you want with that data.
So it's like tap filter. Just to confirm my understanding, tap filter. That filter already exists. There's a dedicated filter for that in Envoy, and what that allows you to. It basically allows you to listen in on what's happening, right, on your requests. And I think if I remember, it just logs it out somewhere, or you define where you want the, I guess, logs or the data from the request to go to. And then you were saying you could do the same if you wanted to, right? You could implement this on your own and just say, hey, run this, make a call to this external processing server. Here's all the metadata that we have, all the information from the request, and then you would just log it somewhere or send it to some log sync or whatever it is, right? Or as you said, the intrusion detection. Let's say you would just basically store it to a database, right? Like you get the data, return the response, store it in a database, and then have another process or whatever do some magic on top of that information. Could be also metrics if you think about it, right? You could collect metrics from the request. I mean, you could do anything at that point.
Yeah, that's I think that's the key takeaway for the filter is largely speaking, you can do just about anything. Some things have sharper, finer honed tools already built in Envoy, and some things won't. And there's a use case for creating a new tool that doesn't exist in Envoy yet, and there could be a use case for strapping a few together to reduce multiple network hops into one. If that's
Yeah, so the guidance would basically be if there's a filter for it already, use that instead of reinventing your wheel, a new wheel or whatever. But if there isn't something, or if whatever's out there, like you need to be done differently, I mean, I would say open an issue first, right, to see if that's something that others might be able to benefit from as well. But if not, then this might be a solution, right, for that functionality. All right. I don't see any questions. People on LinkedIn are still watching, so we'll come back to that offline if anyone has questions. But well, thank you very much, Jacob. Thank you for taking the time and explaining this to us. And I hope anyone who was watching, I hope they found it useful as well.
awesome, Peter. Thanks for having me.
All right, thanks everyone, and we'll see you in a couple of weeks again. Bye.